Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Fibreglass Acoustic Diffusers by the Peddling Pianist. And here are the rules. We have Sudoku, where we need to fill each cell with a digit from 1 through 9 such that digits do not repeat in a row, column, or box. We have region sumlines. The blue R is split by a box border into two segments whose digits have the same sum. So these 4 digits must equal the same as these 6 digits here. And that's how region sumlines work. We have a parity line, where each pair of adjacent digits on a red A must contain one odd and one even digit. So, for example, if this were an odd digit here, this would have to be even, because each pair of adjacent digits must have one odd and one even digit. We have German whisper lines, where each pair of adjacent digits on the green H must have a difference of at least 5, and I will be calling these Whisper 5 lines because Satter came up with that naming convention, and I thought it made a lot of sense because it's very easily extensible. So, as an example, if this were a 3, this would have to be 8 or 9, because on the Whisper 5 lines, the only digits which are 5 or more away from 3 are 8 and 9. That's why they have to be 8 or 9 here if this were a 3. And finally, we have Fibreglass Acoustic Diffusers, which are the name of this puzzle. A digit on the Fibreglass Acoustic Diffusers, which are the upside-down mushrooms, shows how many times that digit appears on Fibreglass Acoustic Diffusers. And Fibreglass Acoustic Diffusers prevent echoes in adjacent cells. That is, a Fibreglass Acoustic Diffuser and its up to 4 orthogonal neighbors contain different digits. Oh, interesting. Okay, so that means... So if we had, say, like a 3 here, that would mean there would have to be 3 3s in these Fibreglass Acoustic Diffusers, because that's how many times that a digit appears in it. Also, every Fibreglass Acoustic Diffuser and the 4 neighbors, 4 orthogonal neighbors, must contain different digits. So that means these different digits have to be different from all of these. This digit cannot be the same as any of these digits for any acoustic diffusers. Same with these 5. Obviously, there's normal Sudoku rules, but for example, here, normal Sudoku rules prevents these from being the same, these from being the same, and these from being the same. But in addition, this digit cannot be the same as that one and cannot be the same as that one. Same with this. This digit cannot be the same as that one also and cannot be the same as that one because of the FADs, the Fibreglass Acoustic Diffusers. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, how many fads do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. So that means there are 5 unique digits on the fads, because there's 5 here, 5 fads in a row, which means they are all unique digits. So to add up to 15, it has to be with 5 unique digits. It must be 1, 2, 3, 4, 5. Let's just double check. 3 plus 3 plus 2 plus 2 is 10 plus 15. Yeah, so these digits have to be 1 through 5. Actually, let's not even do it that way. Actually, we might have to do it that way. Because we don't have any digits. Okay, well, actually, we know 1 has to appear once here. because those have to be unique digits here. Remaining digits in this row are 6 through 9. Also, okay, in box 9, where is the 5? 5 can never be on a Whisper 5 line, because if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not digits. So in box 9, the 5 cannot be on the Whisper 5 line, so they have to be here. In box 6, where is the 5? It can't be here or here because they are Whisper 5 lines, and it can't be here because we have a 5 already in the column. So 5 in box 6 has to be one of these digits, which means this cannot be 5. We also know the 1 only appears on a fad in row 5. So the rest of the fads cannot contain a 1. So they have to be 2 through 5 here. We know one of these two digits is a 5. Okay, so there has to be a 5 in every row. We know there's a 5 guaranteed here. There has to be a 5 here. There must be a 5 in one of these two cells because there's no other 5 available in row 3. So therefore, this cannot be 5 here. Whereas the 5 in row 1, it can only be in one of these two cells, which means this can't be 5, which means one of these two is a 5. So we have a 5 guaranteed here, a 5 guaranteed here, a 5 guaranteed here. Okay. The sum of these 4 digits must equal the sum of these 6. And we know 6 digits at minimum, unique digits, must add up to 1 through 6 at least, which is 21. These are 4 digits without 6, 7. You can't only have one digit from 6 through 9. What's the most these 4 digits can be? The answer would be 9 plus 5, 4, and 3. Right? We know one of these two is a 5. So 9 plus 3, 4, and 5 is exactly 21, which is the minimum these digits can sum up to. So the reason why we can only have one of 6, 7, 8, 9 here is we have 3 digits which are guaranteed to be 6, 7, 8, 9 here. So that means, what does that mean? We have, again, this is at maximum 3, 4, 5, and 9, which is 12 plus 9, which is 21. And this is at minimum 1, 2, 3, 4, 5, 6, which adds up to 21. So they must be the same. So therefore, this must be 3, 4, 5, 9, and 5 cannot be any of these. That eliminates 3, 4, 5, and 9 in the rest of the box. So this can't be 3, 4, or 5. It has to be a 2. And that makes this 1. That leaves 5 there. So 6, 7, 8 as a triplet eliminates 6, 7, 8 in the rest of the row. So this can't be 6, 7, or 8. It's 9. And we have a 2 guaranteed here on the fad. We have a 2 guaranteed here on the fad, which eliminates 2 in the rest of the fads, because we already have 2 2s. So this must be a 3, 4, 5 triplet here. So we have a guaranteed 3 there. This is a 3, 4, 5 triplet here. That's a guaranteed 3 here, and we have a guaranteed 3 in row 4. So this has to then be a 4, 5 pair here, which eliminates 4 and 5 in the rest of the row. So this can't be 4, it's 3. These can't be 3, it's a 4, 5 pair, which eliminates 4 and 5 in the rest of the row. So this can't be 4, it's 3. That eliminates 3 here. That's 3 in the corner because we celebrate because we're close to solving this. This can't be 3. We have a 4, 5, 9 triplet in column 1. This has to be 1 through 6 here. This is 7, 8, and 9. So the 4, 5, 9 triplet here in column 1 eliminates 4, 5, and 9 here. We also can't have 3, so this must be 1, 2, 6 as a triplet, which leaves this as 3, 4, and 5. 9 then has to be one of these two, so this cannot be 9 here. It's 3 or 4. Since 9 is guaranteed to be here, this can't be 9. So this 1, 2, 6 triplet eliminates 1, 2, 6 in the rest of the column, so this can't be 6 at 7 or 8. This can't be 6 at 7 or 8. I should have talked about what an orthogonally connected neighbor is. Anyways. This is 5, this is 2, so this cannot be 2 here. 3 eliminates 3 here. What else do we have? One thing I like doing on Whisper 5 lines is arbitrarily coloring random sets, because you alternate between low and high digits on a Whisper 5 line. And if you want to know why, you can look at one of my Learn How to Sudoku puzzles and figure out what that means. This is yellow, this is orange, and make sure you look at it where there's going to be a guaranteed... Whoa, that's weird. I think that's red, right? I highlighted that with red. That's a very faded red there. But the reason why you know that is because on a Whisper 5, well, again, take a look at any Learn How to Sudoku puzzle that I do with a Whisper 5 line, and you will see why that is the case. Anyways, we have a 3, 4, 5 triplet in column 3, which eliminates 3, 4, 5 in the rest of the column. That doesn't help us very much. We know 1 has to be one of these digits there. These are both yellow. So we have a yellow-red pair. One of these is low, and the other one is a 5 here. That means we have a blue-red pair here. We don't know which. 2 and 5 are both low. 3 and 4 is a low digit. 3, 4, 5 is low or medium or 5. These are all high digits here, and these are all low digits. These must alternate parities here. So let's start marking them as dark and medium. So then these become medium. These are dark. That makes this medium, which makes this dark, medium, and dark. Okay. 3 can't be here. We have a low here. This is not low. This is a 5. These are high digits here. 9 cannot be here, but 9's not any of these. These are low in a 5 also. Interesting. Can yellow ever be lows? The answer is no. Because we have 3 yellows in column 7. We have 3 yellows in column 9. Oh, wait, it could be. Never mind. The answer is maybe. Okay. We are guaranteed that one of these is a 5. The other one is a yellow. Because no, it's not a yellow. It's orange. Because we have 4 yellows in box 9. So that means the 4 or 6 here. So these have to be 1, 2, 3, or 7, 8, 9. for these digits because they are next to two unique digits on a Whisper 5 line. So are these 1, 2, 3, 7, 8, 9, 1, 2, 3, 7, 8, 9. This can't be 9, obviously. And we're guaranteed one of these has to be a 4 or 6. And if the 4 or 6 has to be next to the 1 or 9 in the corresponding opposite set. So this cannot be 1 or 9, period. So we have to have 1 or 9 is guaranteed to be one of these two digits here. The other 1 or 9 must be in one of these sets here. So this has to be 5 with 4 or 6 here, guaranteed. Interesting. So if we have 4 here, we have to have 9 in one of these. That would mean the opposite 3 would have to be next to 8 and 9 on the Whisper 5 line because every other... Well, that's not true. 3 could be there. Never mind. These are lower 5. We have 4, 5 as a pair here. So these fads means 9 cannot be here. But 9 could be there. Okay. So, this is 2. So these have to be different digits. So this cannot be a 5 here. Which means this is a 3-4 pair, which eliminates 3 and 4 in the rest of the box. So this can't be 4, it's 9. This can't be 4 or 9, it's 5. Which means this can't be 5, that's 4, which makes that can't be 4. That's 5 there. So we have 3 and 4 there, that's fine. We have 9 here, that's high. We have 7, 8 there. I don't think this is helpful here, so let's just remove those. This might be helpful here, but I don't really know. 3, 4 is a pair here. That means where is... This can't be 5. So we have a guaranteed 5 here. Okay, 5 can't be here. Okay. This digit cannot be 7 or 8. Cannot be 3, 4, 5. Can't be 1. So it could be 2, 6, or 9. Because of the fad. This 4 sees 7 and 8 here, so this can't... This also would have to see 7 and 8. Can't be 3, 5, and 6. Can't be 1. Okay. One of these is 6. We don't know which. We have 2 odds and 2 evens in column 6. What are the remaining digits in box 2? We have 1, 2, 6, 7, 8, 9. Same with box 1. 1, 2, 6, 7, 8, 9. No 1 here, no 1 here. No 2 here, no 2 here. Okay. This is also 1, 2, 6, 7, 8. No 9 because of 9 in the column. We know 3 has to be one of these 3 digits here. Where is 9 in box 3? This acoustic, this fad eliminates 9 as a possibility because these have to be different digits. This fad here eliminates 9 as a possibility here. So they have to be different digits. So 9 cannot be here or here because a fad, can't be here because of normal Sudoku. So we know 9 has to be one of these 2 digits here, which means this cannot be 9. Remaining digits in row 1 are 1, 2, 3, 6, 7, not 3, 1, 2, 6, 7, 8, 9. Obviously 9 cannot be there. Huh. Oh, if these are both low. So if yellow's low, 4 obviously has to be one of these, which means 3 would have to be here. Which means 3 could not be any of these digits here. 3 would have to be one of these, which would be necessarily next to 2 unique digits on a Whisper 5 line. So if 4 were here, that means 3 would have to be one of these 2. And 3 would have to be next to the 9 and the 8 necessarily. So this cannot be 7 here. If we have that as 7, it would be next to a 3 on the Whisper 5 line, and that would be not possible. So if these are high, the 8 has to be here, which means this can't be 8, this can't be 8. 8 would be next to 3 and 1 or 2. So 9 would be one of these, 7 would be one of these in that case, and then the 1 or 2 would have to be one of these. Okay. You'd have 8 here, 9 here, 3 here. Then you'd have to have 8, 9, then again an 8 here, which is possible. Okay. If, however, so then this would be 5, 6 in that instance. 4 would have to be one of these 2, which would make that 5, which would make that 4. So then 4 would have to be one of those 2. Which is possible. Okay. Otherwise, 4 would be here, but where? I guess 4 could be still there in that instance. So 4 can never be. If yellows are low, 4 would have to be one of these 2, which would mean this would be 5, that would be 4, so 4 could not be here. So 4 then would be in one of these 2 digits. Or, so 4 in box 6 has to be one of these 4 cells. Because obviously if it's yellow, these would be 4, which would force this to be 5 and that 4. Or this is 4, which might force that to be 5 and that 4. And 4 couldn't be any of these digits here. So then 4 would have to be here. if orange are the 4s, these can't be 4 at all. Interesting. Okay. So if yellows are 4, again, these would both be low. And therefore we had 4 lows in row 5, which means this could not be low. So this could not be 4. So then 4 would have to be here specifically. Oh, but that's a contradiction. Because we'd have a guaranteed 4 here, which would force that to be 3. A guaranteed 4 here, which would force that to be 3. And therefore that would be duplicated in column 3 of 2 3s there, which is not possible. So yellows cannot be lows. They have to be highs. Oranges have to be lows. Okay. Therefore, this must be a 4-5 pair. This can no longer be 4. 4 can't be any of these, so 4 has to be here. So this becomes a 4-5 pair here, which eliminates 4 and 5 in the rest of the row. So no 4, no 4, no 4 here. It's 1, 2, 3 as a triplet here. Okay. This is 1, 2. It's next to 1, 2, and 3, so this cannot be 1, 2, or 3 here. These are high digits, so we have 1, 2, 3, so this is 7, 8, 9, no 8 here, it's 2 or 3 here, no 7, 9 here, it's 1, 2, or 3, and we have 6 through 9 here and 6 through 9 here with a guaranteed 6 in one of these two cells. Okay. This cannot be 1 here, so where's the 1 in box 6? It must be here, so this is low and is 1. That means this cannot be low, this is high, this becomes a 2, 3 pair here. 1 has to be one of these digits here, so this can't be 6 because of one of these is 6 there. This can't be 1 because one of these is 1 there. These digits cannot be 6 here because 6 can only be next to 1 on a Whisper 5 line, so this is a 7, 8 pair, which forces this to be a 6. Remaining digits of row 5. We have 3, 4, and 6. But 3 cannot be here because of the 1, 2, 3 triplet in the box. So this must be a 4, 6 pair. So mediums these are dark. Dark cells are even digits, and medium cells are odd digits. 4, 6 eliminates 4 here. So this is 3, which makes this 4, which makes that not 4. It's 3. So these can't be 3 here. It's a 4, 5 pair. We do not have 7, 8, 9 available here. Again, the dark cells are all even. So this must be a 2, 4, 6, 8 triplet. And this cannot be 8 here because of 8 in the 7, 8, 9 triplet in the row. This 6 eliminates 6 here, so where's the 6? It must be one of these two cells, which eliminates 6 there. So these must all be odd, which makes this 1, 3, 5, 7, 9. 1 cannot be here because of 1 guaranteed to be one of these two digits. Where is 6 in row 8? It has to be here. So that's 6. Where is 2 available? We have a 4, 5 pair in row 8 also, which eliminates 4 and 5 in the rest of the row. So this can't be 3 because of 3 in the column. We have a 3, 7, 9 triplet in row 8, which eliminates 3, 7, 9 in the rest of the row. So this can't be 3, this can't be 3, it's 1 or 2, which forces this to be a 3. That means we have the only digits which can be next to 3 on a Whisper 5 line are 8 and 9. So this is 8 and 9, which means this not 8 or 9, it's 6 or 7. This 8, 9 pair eliminates 8 and 9 here, so that's 7. This 3, 7, 9 triplet eliminates 3, 7, 9 in the rest of the box. And the rest of the row, so this can't be 7 or 9, it's 8. That leaves this as a 9 here. Okay. Remaining digits in... So these are odd, so they have to be a 7-9 pair here. Which forces this to be an 8 here. That means this can't be 8 here. 1 and 6, these digits eliminate all of those digits in column 8. That leaves just 2, 7, and 8 here. That eliminates 2, 7, 8 in the rest of the box. Okay. We have a 1-5 pair here, which eliminates 1 and 5 in the rest of the column. So no 1 here, it's 2. No 5 here, it's 4, which makes that 5. 4 eliminates 4 here, so it's 6 and 4. We can remove the coloring here because it's not necessary. We don't really need the coloring here either anymore. So let's remove that. This can't be 2 anymore. It's 1 or 3. 2 means this is part of this fad, and it's also part of this fad. So 2 cannot be here or here. 2 has to be one of these 4 digits here. 9 eliminates 9 in the rest of the column. So this can't be 9 here. 7 and 8 eliminates 7 and 8 here, so that's 6. This cannot be 6 here. It's 7 or 8. That means the remaining digits in column 3 have to be 1 and 9. So that's 1 and 9 there. No 1 here, no 1 here, no 1 here. This is a 6-9 pair, which eliminates 6 and 9 in the rest of the box. So this becomes a 1-3 pair here. That eliminates 1 and 3 in the rest of the row. Okay. So now we need acoustics, or the fad things. 6, this is part of this fad, so this cannot be 6 here. Excuse me. This 6 eliminates 6 here, so that's 7 or 9. No 9 here because of 9 in the row. One of these is guaranteed to be a 1. I don't know which. That's fine. This 6 means this can't be 6 here for this fad, so this must be 2. That means there's no longer a 2 here. We have a 7, 8, 9 triplet now in row 3, which eliminates 7, 8, 9 in the rest of the row. So this can't be 7, 8, or 9, it's 6. That means 9's one of those 2. We kind of already knew that. 2 eliminated 2 as a possibility there. So fad 9 eliminates, this is a fad, means this can't be 9. So we have a 7, 8 pair now in row 3, which eliminates 7, 8 in the rest of the row. So this can't be 7 or 8, it's 9, which makes this not 9, that's 7. There's no 7 here because of 7 in the row. Fads. So we have, this is done. This is just normal Sudoku. Normal Sudoku, normal Sudoku. 6 eliminates 6 there. And 6 here. So 6 eliminates 6 here, whereas the 6 in box 8, it has to be here. Okay. 4 eliminates 4 here, so that's 2. This can't be 2 or 4, it's 8. This can't be 2 or 8, it's 4, which makes this not 4, it's 5, which makes that 4. 5 eliminates 5 here, so it's 1 and 5. 1 eliminates 1 here, so it's 2 and 1. 5 eliminates 5 here, so it's 4 and 5. Okay, no 2 or 8 here. So let's do the fads that are done. That's done. This is done. That's done now. 2 is done. These are done. This is done. This 4 eliminates 4 here, so that's 5, and that's 4. So that's good. That eliminates... So this is done now. 5 eliminates 5 there, so that's 4, which makes that 5. These are done by normal Sudoku. 5, that's done now. This we haven't done. This is done by normal Sudoku. This is done, essentially. This is... We have to figure out what these are. Hmm. 6 eliminates 6. Oh, well, 6 and 9 as a pair, which means this can't be 6. Where is the 6 in box 1? It has to be here. Okay. Is that done? That's done. Hmm. So these two are not done, essentially. Hmm. 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 I'm not really sure how to differentiate these. Huh. This is... Okay, maybe we color these. So this we're gonna mark dark, and this has to be a different digit, so we'll make that red. So then this is dark there. So therefore, this is red here. So red cannot be here or here. So red has to be one of these two. Dark can't be here. So red has to be one of these two. Dark has to be one of these two. Same with dark there, and then red there. Oh, these can't be red because they are in the same fad. Because this is red here, so this cannot be red, which means this is red. So red has to be a 3. So this can't be red here. That means this is dark. This can't be dark here. This can't be dark here. That means that can't be red there. That's pretty clever, actually. So all the reds are 3. All the darks are 1. That leaves this as a 2, this as a 2. This 1 eliminates 1 here, so it's 7. That makes it not 7, so that's 8, which makes that 7. 8 eliminates 8 here, so it's 7 and 8. This can't be 7 or 8, it's 2. This can't be 7 eliminates 7 here, so that's 8, which makes this not 2, 7, or 8. It's 1, which makes that 2. 2 and 7 eliminate 2 and 7 here, so that's 8, which makes that 7. 3 can only be next to 8 on a Whisper 5 line out of 7 or 8, so this is 8, that's 9. This must be 2 and 7, because 6 cannot be next to 2 on a Whisper 5 line, so this is 6, that's 8. This is 7, which makes this 9 here, and that's 6 here. 7 eliminates 7 here, so it's 9 and 7. 9 eliminates 9 here, so it's 3 and 9. Happy 155th birthday, Royal Albert Hall, which I assume have the Fibreglass acoustic diffusers on them. Interesting. That was actually a very cool use of these fads, right? I colored this red and I was like, oh, well, this can't be red because it's in the same fad situation. So that obviously made red have to be a 3. Nice little puzzle. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.